Prove algebraically that when n is an integer, 2n plus 1 all squared, take away 2n minus 1 all squared divided by 4, is always even. Let's try this as a direct proof. Let's work with this expression and see what we get. Remember, 2n plus 1 squared is 2n plus 1, 2n plus 1. And if you expand that out, you get 4n squared plus 4n plus 1. So, our expression is going to become 4n squared plus 4n plus 1 take away, if you expand 2n minus 1, 2n minus 1, you're going to get 4n squared minus 4n plus 1. All of that needs to be divided by 4. So that's 4n squared plus 4n plus 1 minus 4n squared plus 4n take away 1, and then 4n squared minus 4n squared, those are going to cancel out, and the 1 take away 1 are going to cancel, and then 4n plus 4n is 8n, so we have 8n divided by 4, which is 2n, and 2n would always be even if n is an integer. And perhaps since this is a proof, you need to make a statement like that at the end.